So first of all we will take transient structural, then geometry, now I will import crankshaft, import external geometry, I will import crankshaft, generate, then next model, then mesh model, now we will apply RPM to a complete crankshaft. So select body and insert rotational velocity. So rotational velocity components. So along Y component we will apply 100 RPM. Along Y component RPM it is applied in anti-clockwise direction. You can see here. Okay. Then we will insert torque, that is movement, movement, movement. We will apply movement on this part, one end of this crankshaft. Movement component, so it is along also y direction. Suppose it is 50 Newton meter, so it is applied in same direction. Now in analysis setting, define by substeps. So very small substeps we will give 1 and 1. Now next is solver controls, large deflection off. Okay, large deflection setting off. Now insert, here fatigue option is there. Before solving, fatigue option is there, fatigue tool. So click on fatigue tool. So type of the loading, it is fully reversed, zero based, ratio and history data. So out of this we will select zero based fatigue. Then 1 cycle is equal to 1 cycle. The unit is 1 cycle is equal to 1 cycle. You can change this unit. Are you getting? And this is a stress based fatigue life. Stress based fatigue life, there are two types. Here you can select strain based fatigue life also, and here stress based fatigue life. So and means stress theory, it is there, Goodman, Soderberg, Gerber and mean stress curve. So I will select Goodman. Okay? And then you have to insert life, insert safety factor. insert equivalent alternating stress. ठीक है, and solve this. Now this is a fatigue life 1 into 10 raised to 6. This is the fatigue life given by software. Then factor of safety 15 it is suggested, and this is equivalent stress. So there is a little bit deflection. RPM and torque. Why for we are giving? We are giving power. Rotational speed and torque. When you apply, indirectly you are applying power. N into T, that is equal to power. Therefore, we are applying RPM and power. So, you calculate 20 multiplied by 100. So, 2000, 20,000. So, 20 kilowatt power we are applying on this component. Divided by 10 raised to 6, that formula is there. Okay. Now, here you can get different graphs here. This is a load based graph. So load is varying in this way. In this type of theory, load is varying from this to this. Now 0 to 1.5 means what? Increment of load. First of all, load is increment by 0.8, then it is increased by 1.5. Are you getting? Here you can see. So these are the diagrams of mean stress theory. So this line indicates Goodman. Are you getting? This line indicates Soderberg. Every line is given. Gerber, Essen curve, that lines are given to us. Then you can insert fatigue sensitivity also. Fatigue sensitivity, evaluate all result. So this is a fatigue sensitivity. Alter available lives versus loading history. That graph is straight now, but in some problems it is showing alternating available life versus loading history. Loading history means what? Load is reduced by 0.75%, 0.5%, and load is increased by 1.25% and 5%. Are you getting? Load is reduced by 25 and 50%. Load is increased by. So load fatigue cycle. We have to apply load in cycle. So while applying load in cycle, in first cycle load was 100 Newton. In second cycle it was 75 Newton. In third cycle it was 50%, 50 Newton. In fourth cycle it was once again 125 Newton. In fifth cycle 150 Newton. So in each cycle load is varied. So this is what zero based. Now we will do another type of loading, that is fully reversed. In different way you can get the answers. Fully reversed, evaluate all results. Now you can see here it is changed, nature is changed, and fatigue sensitivity it is same. Are you getting? Now what I will do, I will apply one force value here. Insert force. So force I will apply in outward direction. We will apply force, that is component and x component. Suppose 1000 Newton force I will apply on geometry. Okay, and I will delete rotation, I will delete movement, and simply I will apply the displacement or fixed support in this direction. Fixed support we will apply and we will solve this. We will see different results. Now you can see here safety factor it is changed. Are you getting? Now you can see here in the yellow color region. This is the yellow color region. Safety factor is 6 to here 1 to 6. Are you getting? Safety factor it is changed. Yellow color, sorry, blue color region is safe. Are you getting? And red color region it is hardly observed somewhere else. Okay. Now you can see the fatigue life 1 into 10 raised to 6. Then equivalent stress and fatigue sensitivity. Are you getting? Now you can go for analysis type stress life. Instead of we will do strain life. In strain life equivalent alternating strain stress is not calculated. In strain life hysteresis you can plot. Evaluate all results. So this is hysteresis. Stress versus strain. Are you getting? Fatigue sensitivity, safety factor is same and life 1 into 10 raised to 9 now. Are you getting? So one cycle is equal to one cycle. This is a unit. So you can get the procedure is same for all type of analysis. For every analysis you can go for calculation of fatigue life. Now we will do a static structural for same component and we will do its fatigue analysis. Same geometry, model. Now you can see generate mesh. Simply give fixed support, then simply apply force. In any direction you can apply the force because it is a rotating component. 1000 everything either you give rotation or force. Rotation and torque you can give at a time. Torque. Torque means what? Force into displacement. Force into radius. Indirectly you are applying force. Are you good? Now solution insert fatigue tool. Now in fatigue tool insert. Now fatigue tool fully reverse is there. We will take now ratio type of fatigue analysis. Then we will take here strain life. Okay, equivalent 1 minus strain, or you can select here types of strain. There are different strains are available. Fatigue life based on 1 minus stress, fatigue life based on shear stress, fatigue life based on principal stress. Are you getting? Fatigue life base you can calculate. Now mean stress theory it is there. We will take Morrow or SWT. These two types are available in strain life. These two types are available in strain life. Stress, Soderberg, Essenker, Woodberg, these types are available. These are available in strain life. We will take Morrow, then insert life, then we will take strain life. We will take Morrow, then insert life, then we will take strain life. We will take Morrow, then insert life, then we will take strain life. We will take Morrow, then insert life, then we will take strain life. We will take Morrow, then insert life, then we will take strain life. We will take Morrow, then insert life, then we will take strain life. We will take Morrow, then insert life, then we will take strain life. We will take Morrow, then insert life, then we will take strain life. We will take Morrow, then insert life, then we will take strain life. We will take Morrow, then insert life, then we will take strain life. We will take Morrow, then insert life, then we will take strain life. We will take Morrow, then insert life, then we will take strain life. We will take Morrow, then insert life, then we will take strain life. We will take Morrow, then insert life, then we will take strain life. We will take Morrow, then insert life, then we will take strain life. We will take Morrow, then insert life, then we will take strain life. We will take Morrow, then insert life, then we will take insert safety factor, then insert fatigue sensitivity and solve this. Now you can see here safety factor. A load was applied in different direction. Fatigue life calculations are shown 176,439 minutes minimum fatigue life. 176,439 minutes and maximum 1 into 10 raised to 9 minutes. This is a fatigue life. Minimum it can sustain 76,439 minutes. Under that force, are you getting? Then next, this is the fatigue sensitivity. Now you can see the graph is generated. Loading history versus available life cycle. Are you getting? Loading history. Force we have applied 1000. Are you getting? So in the down cycle, 25% load is reduced. 50% load is reduced. 25% reduced. 50% reduced. 25% increased. 50% increased. Are you getting? So this happens in fatigue analysis. Safety factor. Now we will see a fatigue life over stress based. Stress means stress theory we will select now Soderbergh. Are you getting? Soderbergh we will select and solve. Then you can see fatigue sensitivity is little bit changed. Are you getting? Fatigue sensitivity is little bit changed. Now fatigue life on basis of stress. 5, 4, 8, 6 minimum and 1 into 10 raised to 6 maximum. Minimum and maximum fatigue life. Then safety factor. In some region it is changed. Are you getting? So you are going to get answer at any point. We know this procedure. Select mesh, select point. We will select suppose we will select this point. We will give some name to this point. I will give name point. Then suppose we want life at that particular point. So insert life, geometry selection, name selection and point and solve this. So you will get fatigue life at that particular point. 1 into 10 raised to 6 is the fatigue life at that particular point. Are you getting? Suppose you want to see hysteresis, it is not available at particular point. Hysteresis is available in strain based life. Are you getting? Fatigue sensitivity is available in stress based life. Are you getting? So these graphs you have to go for capture image. I think image to file. Okay, image to file. You will get these graphs. Let me check whether it is available or not. One. Okay. So in this way you can get graph. So for different types of fatigue analysis, you can get separate graph. If you do 4 types of analysis, you will get 4 graphs like this. Alternating stress versus loading history. Now in fatigue analysis, listen carefully. Material properties are given input. Now which are these material properties? These material properties are alternating stress versus strain. Now these are inbuilt properties. Now where are these? You see here. Alternating stress, mean stress. So you can see these material properties are automatically given input. You can save this graph. You can save this image. You take this image in your report also. All diagrams, all reports you take in your report. Okay. So this table is available for many materials. Suppose you want to change the material of this crankshaft. So how to change the material? So here engineering data source option is available. Okay. Go to this. Then here you will see the list of materials in general materials. So select general materials. So in general materials, some materials are shown here. So I will add, suppose I will add stainless steel. Stainless steel it is added to my list. Okay. Now here you can see structural steel it is already there. Uh, Now here you can see once again engineering data. Engineering data source. So we have selected here stainless steel. No? We have selected stainless steel. It is added, and you can add this stainless steel. Add to B2. Okay. Now here during in meshing option or in geometry there is option of adding material. Are you getting? Suppose this is a part body. So here structural steel, this option is there. Are you getting? Structural steel. You go to part body, material. The structural steel is by default taken. So you can select here new material. Click on OK, and here structural steel, click here to add new material, or you go to engineering data source, general material, stainless steel we will add. Are you getting? And these are the values of structural steel. Likewise we will see now stainless steel values. So these are the values of stainless steel. You can see here stainless steel. Material properties are feeded there already. These are the material properties of stainless steel. Okay, so in favorite is these three. Listen carefully. Afterwards, you have to click on favorites. So favorites, your favorite materials are these three. So out of this, I don't want air. Suppose I want only structural steel, or I want aluminum alloy. So just click on this. So here tick mark option is there. Okay, tick mark option means you are selecting that material. You are selecting that material. Now you have to click on update material, sorry, update project. Go to project and update project. Okay. Now project it is updated, but option is there structural steel. Now here when you click here there is another option stainless steel. When you add them to favorites, stainless steel option is there. Once again you have to solve. Now this answers will be different. Now material is changed. Are you getting? We have taken stainless steel. So adding material is not difficult. Already material properties are also there in the ANSYS workbench. In APDL we have to give input material properties, but in workbench it is not necessary. Now you can see here stress versus strain, equivalent stress, minimum, maximum. Something it is changed there. It is okay, na? Stainless steel material we have selected, no problem. Hmm? let it be. ठीक है, you do analysis. Hmm? Missing strain life parameter. Okay. So here we have to select strain life. We will select tomorrow. Hmm? Then we will solve everything. Fatigue. There is a more problem in fatigue module. Stress strain life parameter. Okay. It is there or not? We have to check. Alternating stress strain life parameter should be there. Aluminum alloy. So in aluminum alloy, alternating stress, it is there. Okay, it is there. Tabular. So interpolation is there in semi-log format. Okay, let it be. For stainless steel, it is not faded, I think. So we'll go to once again structural steel and we will solve. Yeah, it is okay now. Now you solve. Uh, you can take another part. You take any part for fatigue analysis. Hmm?